Not all lines, of course, are parallel to the axes. Not all the time the point we know is the y-intercept. That's where the point-slope formula comes in very handy. Essentially, it's the slope formula itself, but rearranged. So we write it as y minus y1 is equal to the slope times x minus x1. So all we need to know is a point and a slope. We can get the equation of a line. So if it passes through these 2 points, well, first thing I do is I'll work out the slope. It's -2. I have a point. Well, I've got 2 points. Doesn't matter which one I use. And I've got the slope. Sub it into our point-slope formula. Expand it out. I've put it in general form, 2x plus y plus 2 equals 0. We get these sorts of questions. Find the equation of the line that passes through 2, -3 and is parallel to this. Okay, parallel slopes are the same. So it'd be tempting to do it this way. If I rewrite it so it's y equals mx plus b, then the slope's -3/4. Put it into the point-slope formula, there's our answer. But there is a quicker way. Have a look at the answer, have a look at what it was parallel to. And what do we notice? Well, because they're parallel and the slopes are the same, what ends up happening is the coefficients of x and y will also end up being the same when we write the equation down. That being the case, I could say, well, I know it's going to be in this form. 3x plus 4y plus some number equals 0. Has to. Well, I know a point that's on the line. If I substitute that in, I can work out what k is. Oh, k is 6. There's the equation of the line. So it's using the pattern rather than the formula. And we can do the same thing with the perpendicular. The traditional way, I guess, of doing it is, well, let's rewrite it. Okay, slope of this one's 9 on 4, therefore the one I want's minus 4 on 9. Put it into the point-slope formula. Here's our answer. But again, if we compare our answer to the question, what do we notice? Well, the numbers have swapped round, but also the sign in between them has changed as well. Well, that's because they multiply together to give -1. That pattern should always happen. So an alternative way of doing this is I could say, well, hang on, I know it must be in this form. The numbers swap around and I'll change that minus to a plus. I just got to work out what the constant number is. Well, I've got a point that's on the line, substitute it in, and oh, it's -60. There's the answer. So playing with patterns rather than the formulas. If you had to prove 3 lines were concurrent, so we talked about collinear the other day, where we had together on the same line, this one's sort of like the other way around. The lines are on the same point. So they all go through the same point. So how would I do it? Well, I'd solve 2 of them. I'd just pick a pair, solve them simultaneously. I'd find their point of intersection. And then all I've got to do is show that that point of intersection is on the other line. So I'd substitute it into the other one. And if it satisfies, then yeah, these lines must be concurrent. They all go through the same point. That'll do us for today.